Okay, is everyone ready?
Yeah, sure.
Yeah. Okay, so we're going to be presenting our bachelor thesis, which is within with regards to foresight AI and democratizing energy insight through natural language interaction, written by me, Kevin, and Kaamya. And then we go to the next slide. So today's agenda, we don't need to explain who Piscara is, but we're going to talk about the assignment details, talk about the motivation for why we chose this assignment, talk about our problem statement, the research approach we chose, some of our results, and future work that needs to be done.
Right. So on to the problem. So the assignment detail that we got was about energy management systems. So essentially, there is definitely a lot of data that is being collected by these systems. But access to these different data sets does not mean access to insights, which is where we come in. Because not having access to the insight, it can occur due to lack of domain expertise. And this creates a knowledge barrier and creates a problem when it comes to accessibility to information for users, regardless of their background. And this can also contribute to weak decision support because all the decisions that need to be taken based on different energy insights is limited to a certain number of people who actually have that domain expertise, as a start at least. Yeah.
Okay, so the motivation for choosing this assignment. So when we started looking at the bachelor assignments we could choose from, we thought it was interesting to work with Piscata because we don't really have any experience with the energy domain. So we thought that was interesting. And also we got the opportunity to work with a business and actually try to solve some real world problems. And we also found it interesting that we could actually like start to get to know more about AI as we're choosing to apply to a master program in regards to AI. So that was something that really awoke our interest. And yeah, so a main part of the system is then RAG. So RAG stands for Retrieval Augmented Generation. And in short, it's basically that when you have a question, you have the LLM, and then you augment the LLM's capabilities to retrieve relevant documents so that it can augment its response with the relevant documents. So that's why it's called Retrieval Augmented Generation.
Yes. So as part of our course at NTNU, or like our study program at NTNU, we had to conduct sustainability analysis, because these past few years, sustainability has become an increasing focus in our course and in a lot of other courses actually. So this framework you see has 5 different dimensions, which are the different sides on the pentagon. And you have different layers, such as immediate, enabling, and structural, which look at the time period. So immediate is something that affects in terms of like something that is very quickly. Enabling is like, okay, 2-3 years in the future. Structure is much more at a larger scale. And during this analysis, because the idea of conducting this analysis was try to incorporate it into our project in some way. And for us, we made it so that it was one of our actually like biggest focus, because it's in our problem statement, which is how can a domain adapted LLM system support interpretation of energy data while balancing quality with token usage costs. So there's a lot going on there, and it's a pretty broad thing, which is why we divided into 3 parts. So these are the research questions that we had. The first one has to do with interpretation support. So how is the system design, the architecture, the different UI interfaces, or the user interfaces that we have, how does that all contribute to the interpretation of the energy data for all users? Then we have response quality, which looks at some metrics on the RAG system, in addition to how this response is presented to the user. And lastly, we have cost efficiency, which is again with the system configuration of the backend RAG system that we take into account. And this covers all the dimensions that we have in our problem statement. Another thing is that we follow the OATS research framework. So this is an approach you take when investigating a research question. And for us, we had 3 different research questions. So the way it works is that you usually have one research strategy for a research question, which defines the overall investigation, overall approach you take in order to answer that specific question. Then you have the data generation methods, which is how you actually collect the data in order to answer the question. And then you have the different data analysis. And so we use a mixture of these. And what we have actually come up to is design and creation and experiment as our 2 main research strategies. So all of the things that have to do with the system, how it affects the users, all of that goes into design and creation. While experiment is everything to do with the backend RAG system. And design and creation has things such as observations, usability testing, interviews, and so that we will come back to later.
So when it comes to the development process, here you can see like the time, how like the time spent changed during the last around 5 months. Actually, we started working on this task a little bit before January. We sent out the first email in December
Yeah.
to ask a little bit more about the tech stack so that we could do some research during the Christmas holidays, and that has really helped us when it comes to the results. So at first we worked a lot, and then the last month and a half we had other subjects we needed also to focus on, and then we moved more into the report and the different documents we also need to deliver to engineer.
Yes. So now we're going to talk a bit about the results that we have. And for the first research question, as I mentioned, we had usability testing, interviews, but we also had a WCAG analysis. So before we actually implemented the front end, we got a prototype or a general wireframe of how it should look at from the beginning. And based on that, we conducted some WCAG analysis. WCAG, by the way, is Web Content Accessibility Guidelines. So they talk about how we can make everything on the screen accessible to all users, regardless of their background. So it's something that we really focus on. And based on that, we implemented our front end. But before that, so this is how the full architecture looks like. Obviously, we were working on the front end of Piscata, so we had an existing system that we were adding onto, where we got access to the relevant part of the code gradually as the project progressed. Then we have the front end that communicates with the proxy server that, again, belongs to Piscata, which is the data layer. That's where we get all the information from. And then the front end communicates with the backend service in order to send requests to the LLM providers. So the ChatGPT and Claude and stuff.
So when it comes to the RAG backend service, I'm going to delve in more into that in the next slide. So now I can talk about the different adjacent services. So we used Phoenix as an open source platform for tracing and evaluation. So if you send the question to the system, you get a response with the different latency for the different stages and how much tokens and the cost based on the model you chose. So based on if you have a LLM from Anthropic or OpenAI, and also which specific. And then you have the PostgreSQL database, which stores feedback. You have an option to give feedback based on the response, and then you can use that later to improve the system. ChromaDB is the vector database service that actually stores the documents that are chunked. So this is actually the part where you actually retrieve the needed documents to generate a response. So now we can go to the next slide. And here is like the RAG pipeline. So in the first stage, you have an ambiguity gate. Sometimes if you try to send a response without enough information, it will give you a response saying that you need to check this boxes based on the question you're trying to answer. And then you have something called hide. So hide is hypothetical embedding and document embedding. And it's basically that if you have a question, it will generate a hypothetical answer and use that to look for similar documents. And this is optional because it increases the latency and then it takes longer time for you to actually get an answer. So that's why it's optional. And then you have the ChromaDB retrieval. When you get the documents, you can have an optional re-ranking to like further extend how you rank different documents. You have different algorithms. Some of them are semantic with vectors, other are with metadata filter. So that's also option you can choose yourself. And then you go to the prompt construction, which has like words and then placeholders based on the documents you retrieve. You go to the LLM generation and they have a citation validation so that you can actually fact check the response and click and see actually which PDF and which part was used to generate this response. And then we have like a system to make sure that it can actually annotate the chart in a structured way and that you don't just get a kind of like a word slop. So this is like the overview picture of the RAG pipeline. And then we go to the next slide. Okay, so you have document creation and discovery. So an essential part of the process is the documents. If you have bad data, you also get bad outputs. And therefore, early on, we needed to try to find some documents and process these. So we found something called OpenAlex, which is a tool where you can give a document and then based on that document, it will try to find other papers which are similar. And we used that technique to gather some documents and also got some more from Jørgen so we could practice and test our cleaning pipeline and through like iteratively improve that part of the project. And go to the next slide. So here we also have observability and evaluation. So this is the Phoenix platform. Here is the experimentation page. And first I can talk about the like how we actually create the data set. So you have a question, reference, answer. So based on the documents you already have chosen, it creates a question. You use an LLM actually. So you have already chunked the documents into different parts. You create a question based on the documents. You have a specific answer, and then you connect and reference the document that wasn't needed to answer the original question. And then you have generated the data set you will use, if you go back to the former slide, in the evaluation. So here we have 4 different metrics, and I'll talk about them a little bit later.
Yes. Now a big quick demo. Yes. So this is the dashboard page. And as you click on the right corner button there, you open up the chatbot. And you can select between the different models. We will talk about this later on too, but one of the things that we did is that based on our analysis on token usage cost, we recommend which model you should use for different things. And then for sending a request, you have a quick analysis section there. So you don't have to think about actually like what question you want to send. You can just choose one of the predefined ones in order to reduce the friction. And also like this helps guide the users into getting the response that actually works. Because we have tried a few different combinations and we have decided that, okay, this one is better at giving answers than the other ones. Another thing is that, of course, there's a lot of different chart types that we have, and there is no one answer fits all. Because in the early stages we were trying this out, and like if you have a chart with a trend that goes upwards, obviously it's able to recognize that. But if you had an accumulated graph where it was always going to go upwards, that also got the same answer as a normal chart. So of course we need some different ways to process this information. The way this was done is that the front end actually like processes the data based on the chart type. So this was done a bit manually because we didn't want to give the LLM the responsibility of actually making calculations. It is really bad at maths, so we actually just process the data before sending it to the LLM so that all it has to do is make conclusions out of the data. And this was fit for the different types that we have. A bit more, as you see here, you get a quick like summary, like too long, didn't read type of summary. And you can see that it has identified roughly 69% of the week's growth occurred during Monday to Wednesday. Then it talks a bit more about how it got to it, like like end total and overall growth. Then it also talks about any anomalies it found. Another thing that we do is that we send in information about holidays so that suddenly, if it sees a spike, or not maybe not a spike, but a downward fall, it is able to connect it back with the holiday that was connected to the day. As you see, the chart data is also annotated. This helps visually connect the information that was presented in the text. And there you see, after conclusion, a bit on the bottom, there is something called reflection prompts. This is because, of course, the LLM doesn't have access to absolutely everything. For example, when Corona happened, the LLM didn't get access to that information on the second. And so it actually returns a few questions back to the user to prompt them to think about whether there were other external factors that affected the different trends that we see. And lastly, you also have the sources at the bottom. And you can also send widget questions directly from the widget instead of choosing it in the panel. So this is how it works. And there is one more slide. Yes, here we show a bit about conversation history. So of course, it's always helpful to go back to where you left off. And the titles are generated by the LLM. As you see, there's a lot of same ones because I actually send a lot of the same data. So it always generated the same title, but that's why you can obviously have an option to rename the chat. This is how it looks like. You get the same view. You will see what type of dashboard or page it's connected to. Now, this is an energy analytics one, as shown under the title. And when you click on going back to it, it opens the last context that was used to communicate with the LLM. If it did not have access to that information, it would have just responded that I don't have access to it, but it still opens the relevant page so that you can continue working on that one. That's a quick demo of the front end. And so in order to summarize everything, because now this was the first research question, the design and creation strategy was very much focused on the first research question. We conducted VCAG analysis and after on the prototype and our implementation. On implementation, out of the 35 criteria that are required by the Norwegian government, we have covered every one of them. There are 5 that are partially met and 7 that weren't applied. So these 35 requirements come from Piscata being a private company, and we were looking at the website part. So that's where it comes from. Then we conducted 2 interviews with Jørgen. One was before we implemented our solution. It was at the very start of the project. This was in order to get a baseline of how the existing system works, and it gave us the basis to create the user stories, but also gave us a point of comparison for the implemented system. And I did an interview with him, and there was a lot of good feedback. And a lot of the things that we have implemented have helped answer the research question, which is, or help support the research question, which is whether our system actually supports interpretation of energy data. And all of our data collection shows that it absolutely does do that. And now we're going to go on to the second research question, which is response quality. Again, this is not just the quality of response that is generated by the LLM, but also how the interface around the response presented, how that affects how the users perceive the response quality.
Okay, so when it comes to the response quality, and also we can take it back to the chart shown earlier. You have 4 different metrics which are used with the LLM as a judge. So because we didn't have enough, we had a lack of people to interview, we chose LLM as a judge, which is a type of evaluation system where you use an LLM to evaluate other LLMs. But this can lead to different types of biases. One of them is that LLMs rate the same model family higher than others. So then when we had OpenAI model, we chose an Anthropic model to compare. And these were the 4 metrics which were chosen and used. And this ranges from a score from 0 to 1. And then these were aggregated to give a total response quality. And if you go here, you can see that in general, Cloud Opus was the best, followed by Sonnet and Haiku, and then you had ChatGPT 5.4 and 5.2. In general, the total response quality didn't have that big of a difference, and each model has different strengths when it comes to the quantitative versus the qualitative metrics. And I'll expand on that now. Kaamya, come first.
Yeah, so when it comes to response quality, there were a lot of design choices that also added on to having a better quality in the responses. So we have the concise summaries, so the too long didn't read section, quick conclusion. The text is also very clearly readable. There is not too much text that is put together in one place. There are visible citations. The user can click onto them, and it opens up the document actually in the browser, so you can have a look at them. Then you have the reflection prompts, which is again another good feature to get external context that the LLM doesn't usually have access to, and the contextual explanations that are grounded in the chart data and the holidays data that we send in.
Okay, so now we're going to interpret the results, which is our part of the research question 2. If you go, we can talk about different.
Oh, did you mean the quality tokens? That's
Yeah, okay, so research point 2 was the quality tokens.
Yeah, so we can first talk about research question 3, and then we can come back to it. Yeah, so yes, so if we were to interpret research question 2 quickly, it's that as Kevin mentioned, the quality scores were generally the same, and that's why we actually need to look more on the research question 3 in order to understand the differences between these models. But on the qualitative side, from design and creation, our system creates a good foundation in order to trust the responses more because of the different choices that were mentioned earlier. So again, research question 3 is about the token usage and the other metrics such as latency, time to first token, which Kevin will talk about more.
So when it comes to Cloud Haiku, it was the most efficient model. It had the lowest time to first token, pretty low cost per request, and it had pretty strong quality for the price and the highest quality per dollar. If you go to the next one, GPT 5.4, it was pretty similar to cost and quality with 5.2. And when it comes to the context recall metric, it had the highest score there. And also when it comes to response relevancy, and it had the lowest total latency. So the difference between time to first token and total latency is that different models have different token speed. So let's say even though Haiku could start answering a question before ChatGPT 5.4, ChatGPT 5.4 would finish answering the question before, even though it would start later. So that's the definition. And yeah, GPT 5.2 was pretty comparable with GPT 5.4. There weren't any big differences between them. And Claude Sonnet was a pretty balanced model. It had the second highest quality score, but was more expensive and slower than the GPT models, but less costly than Opus and had a strong faithfulness score. And last but not least, we have Cloud Opus, highest quality, lowest efficiency, and as you can see in the PowerPoint slide. And in general, when it comes to like using LM as a judge, because LMs aren't like deterministic, it's more it makes more sense to look at the scores as more of a qualitative judgment compared to different quantitative metrics such as time to first token and latency. Yeah, so that's something important to note. And then we can go to the next.
Yeah, and just like based on these findings, we based our front end, the whole like models provider section. That's where we have added different icons in order for the user to like take a choice themselves. Because as our problem statement was understanding the balance between quality of responses and the LLM token usage cost, we found that there are some things. There is no one optimal answer about which of these is the best one. So it totally depends on the user to see what fits them. But of course, we come with some suggestions, such as this one. If you want highest quality, you can use this one, but it has lowest quality per dollar, so it's gonna cost you a lot. So these kind of things. Yeah.
So now we can talk about future work. So we have divided this into 3 categories. You have short-term improvements, long-term improvements, and some stuff you need to work on continuously. If you go here, these are, of course, more expanded in the actual bachelor thesis, but in general, we need more human evaluation. We need more qualitative evaluation to make sure that the general interpretation from the LMS judge also is in accordance with the humans. And we also have the feedback option and feature in the front end, so you can continuously gather information about the responses from the LLM system. And of course, accessibility is important, so we still have some improvements when it comes to the front end to increase that part. If you go to long-term improvements, RAG is a relatively new technology, and there are still coming new people are still finding new stuff and improvements. So that's important to look at, be up to date with the pipeline and how you can increase the retrieval quality and the consistency. And also when it comes to the documentation, also part of something that's continuous. Based on the feedback, you can try to find out if the documents actually are good at answering the question, and the document at the backend can be switched so that you actually have only relevant documents and don't fill up the ChromaDB vector database with irrelevant stuff and information. Yeah, thanks for listening.
We had.
Thank you. Can I ask questions?
Yes, of course,
Whatever.
of course.
When you did the BACOG analysis,
Yes.
did you look at only stuff you made or
Yeah.
also on his stuff?
We all looked only at stuff we made because there were a lot of criteria that we had to look at, and so the scope was really short. So,
Okay.
yes.
You concluded that the Haiku model was the best model?
Most efficient.
Most efficient.
So
Yeah.
if you try to get the best balance between like cost and like token usage and like performance. But if you only cared about performance, it was the like most expensive model, aka Cloud Opus.
Which wasn't a surprise.
Yeah, which makes sense also.
But your conclusion was that Haiku was good enough for the task.
Yeah, for most tasks, yeah.
For like easier tasks at least. Yeah.
Yes.
Yes. Are there any questions from others?
Did you kind of look at how much cost it took for an average analysis?
Some few cents. I think I remember at least like a basic question. I think Opus was like 2 cents. Yeah, so it wasn't that expensive, and even less with like Haiku and stuff. So I think like depending on how much someone will use the platform, I don't think cost would be a problem. So I think most people would in practice just use Opus because the price per request was pretty low. And something that was like more expensive was actually the data set generation, because and the like evaluation metrics that cost that much more because we need to create many like many different questions with an LLM, and we need to test each. Like, okay, you have question A, and then you have 5 different models, and then they evaluate like get evaluated based on 4 different metrics. So like with the metrics, it became a lot of like runs, and that took even more time than the document curation. So sometimes I remember when we chose like the most advanced models to compare each other, it took up to 5 hours to have a full run. So yeah, so the picture you saw earlier with like the different colors and stuff, that with 40 questions, it took 4 or 5 hours. At least on my laptop. So I think that depends on which computer you have and stuff.
Yeah.
Did you make an assessment of if the RAG approach was the right for task?
Like we considered earlier, at least like, yeah, we.
Because there were some documents that we spoke about that didn't really generate good answers without having access to them.
Like, how can I say anything? I can try like to keep. So a big part of like our research was based on a course in the website called deeplearning.ai, based by like a British American AI researcher, Andrew Ng, and like we compared fine tuning compared to RAG, And then we found out, based on like different books he mentioned in the course, that like you could take RAG and also add fine-tuning, but you should start with RAG first. We considered also adding something that Tim mentioned, which was like knowledge graphs and using like graph RAG, and then like comparing, like adding it together with vector. But we found out that like vector was good enough. It was easier to implement. So we prioritized just having like, okay, let's do vector RAG first. And then if we have time, we could add like graph RAG, and maybe then we could add the fine-tuning. So like we just start like with like the smallest building block, and then I guess in the future you could choose to expand the system if you think that can help increase the quality of the responses. So I hope that answers your question.
Any questions from anyone that joined us, please? Oh, my camera's gone. Wait, I can probably get them up on the screen too.
Stop sharing with them.
Yeah.
Listen, they can see this.
Have you handed in the paper?
No, I think we have 48 hours left. We're basically done. So right now, we're just like reading up again. We need to actually record a 30-minute video. So we just have some few stuff to do, but we're basically done. The last few weeks have been just like trying to improve on the text and do other adjacent stuff, which isn't related to the work we're doing for Pescada. Yeah.
You can't document the amount of hours.
Yeah, that's something we need to do for NTU, which is like one of our
I
assignments.
understand that, but did you, was that the entire team? So when you worked 20 hours, it wasn't an average per person?
No, it was both of us.
Yeah.
It was accumulated, yeah.
Accumulated. So
Yeah.
that week was like we tried like to, because we didn't we were unsure of the scope. Like, so our strategy was like, let's work really hard at first, and then like if things are going good, we can scale down, as you can see. So it's been pretty like chill the last few weeks, and then we had time to work on other subjects we had this semester.
Yeah. If I come early in the morning, always here.
Yeah.
If I come late in the afternoon, you're still here. So,
Yeah, we just come in on the weekends.
Yeah.
So we're gonna miss having this place, though. It was really nice having a workplace here and having easy contact with everyone. Definitely.
Yeah, it's been a pleasure having you here.
Thank you very much. Yes, then that concludes this meeting, and thank you everyone for joining. We really appreciated working here, and yeah, I hope you guys learned something new, maybe. Yeah. Yes. Okay. No, the camera is gone. I was about to wave. Bye. Thank you.
Okay, bye.
Bye.